we are going to look at a few more examples of inverse variation. Before we looked at a very simple inverse variation where y is inversely proportional to x. We looked at the example of the painters. The more painters there are, the less time it's going to take them to paint a fence. We looked at this formula. We can make the formula look a little more complicated and still know what we're doing. Look at this example. We could say y is inversely proportional to not simply x, but x minus 1 squared. Which, this is a sentence, we can summarize it by saying y is inversely proportional to, which means we're going to, because we said inversely proportional to, we write the 1 over and put whatever it's inversely proportional to as the denominator here. It's inversely proportional to x minus 1 squared. So x minus 1 squared. They also tell us, well, when x is 3, y equals 2. So find the formula for y in terms of x. So we're looking for the formula where we say y equals something with k and something with x, right? This statement can be translated into y equals some constant divided by x minus 1 over 2 squared. All we need to do is to find the constant. Yeah, we know two of the points that go into this, two of the values that go into this equation. If we plug those in, we'll be able to solve for k and find our general formula. So let's do that. Let's plug in 2 for y. 2 equals this k that we're looking for, divided by 3 minus 1 squared. 2 equals k divided by, well, 3 minus 1 is 2. 2 squared is 4. So k over 4. Multiply each side by 4. Which gives 8 equals k. So we found our k value. We put that into our formula to get our general formula that will allow us to find any combination of 2 points. X minus 1 squared. So now someone could say, well, what if x is, what if x is 2? X is 2. What does y equal? What we do is we plug in 2 for x. Let's do that over here because I like to move around in very illogical directions. We plug in 2 for x. Y equals 8 divided by 2 minus 1 squared. So what does y equal? Y equals 8 divided by 1 squared. What is 1 squared? 1 times 1 is 1. So y equals 8. Y equals 8. There you go. And using this general formula, you could find any x value when given a y value or any y value given an x value. Let me give you a nice real life situation where we have two variables and they are inversely proportional to each other. There is such a thing as a gravitational pull between two objects. I remember being amazed when I found this out. Objects, we aren't only pulled down towards Earth by gravity, we're also being pulled towards each other. You had no idea. Cool thing is, there's a formula in physics describing this gravitational pull. F is the gravitational pull. Yeah. it is equal to some constant divided by the distance between the objects squared. The distance between these objects is this, right? This is d. This constant is a function of normal gravitational, how did I write that? This k is the product of the mass of this object times the mass of that object times the gravitational constant. And so depending on the mass of these objects, this constant changes. But if we know the masses of the two objects, we know our constant, and then we can figure out the gravitational pull between the objects depending on the distance between them, which is pretty cool. So let's say we have masses that give us a constant of, let's say our constant with two the constant is dependent on the masses of the object. So say we have a constant of 100. I have no idea. The gravitational pull between the two objects, this would be the formula for these two objects. The gravitational pull between them is inversely proportional to the distance between them. Let's say there's a distance of 2 meters between them. So distance equals 2. Then the force that pulls them towards each other would be 100 divided by d squared. D is 2. 2 times 2 is 4. So this force would be 25. I'm not going to go into units and stuff. This meters might even be completely off. This 100 might not make any sense. I just want you to see that in physics, like in real life, there's many things that are inversely proportional to each other. And in this case of the gravitational pull between two objects compared to the distance between them, the gravitational pull is actually inversely proportional to the square of the distance between them. So it's not just to make life complicated that that I introduce situations where a variable is inversely proportional to something squared. That is not just to practice with the numbers, it's actually a real life thing that you run into when looking at gravitational pull between two objects. I think that's awesome. I hope you do too. Anyway, good luck with the exercises, and I'll see you later.